All right, here we go. Okay, so normally I would walk you guys through what the schedule looks like over the next couple of weeks before we start. But like many of you, the next couple of weeks are unplanned. Just kidding. Sorry, bad joke. But I haven't planned the next couple of weeks, so let me make sure that I get that out and get it all on paper. Now we're starting to laugh. Okay, that's good. All right. So anyway, so yeah, we're going to learn the mean value theorem today, and then we're going to I'm going to actually get some plans on paper, and we'll figure out where we're going to land in the next week and a half to 2 weeks, and then it'll be finals week. Can you believe that we are 3 weeks away? 3 weeks away from, finishing the first semester. Yeah, it'll be tough. Yeah, it'll be tough. The question was, will the final be hard? And yeah, it'll be tough. It'll be a tough final. Sorry, I'm just making sure that it's recorded. Sorry?
Is it going to be curved?
Yeah, everything has been pretty well curved for you. Yes, you'll have some free response. Mm-hmm.
So like,
and I'm not sure how that's going to work yet. I'm not. What I did in the previous class is what I took 1 hour to do a free response before the final exam, and then on final exam day, you just did multiple choice. And that gave me time to grade it over the weekend or whatever. And then when you took your final exam, I could grade the multiple choice and then give you the grade almost before you left, depending on how well I did finishing up the grading or how quick I was. Okay? All right. We'll talk about next week, tomorrow, hopefully. Okay, I'll have more of this planned out. So today we're going to talk about the mean value theorem. So there are a few what they're called existence theorems. The mean value theorem is one of those existence theorems. And basically, IVT is one of those existence theorems. It just says that, like, yes, something does exist at that point, or on that interval or something, right? So the mean value theorem is one of those. The formal statement just says, if a function f is continuous, so what's the first thing we're going to have to say about it? It's continuous. All right, so it is continuous on a closed interval a to b. Also, we're going to have to mention that it's differentiable on this. The reason it has to be differentiable is because we're about to talk about its slope. It has to be differentiable on the open interval a to b. Then there exists a number. There must be some number, an x value, so that the instantaneous slope equals the average rate of change. Now, logically, that makes sense. If I drive from here to Florida and I say my average velocity or my average miles per hour was 60 miles per hour, then you know that I went 60 at some point during that trip, right? That's all this is saying, is that if I have some interval, a closed interval, on a to b, here's a, my x value, and b, my x value. All right, all it's saying is that that average rate of change is equal to an instantaneous rate of change somewhere along the interval between a and b. You can see that the slopes match right there. Is there another point where the slope matches in this graph? Where the instantaneous rate of change equals the average rate of change? Probably right around there, right? You can kind of think about what that tangent line would look like. Does that make sense? All right. So then there's a little translation there. I think I've done my best to kind of translate it with you. and give you a picture. So go back and read that if you need to. All right, so now let's read some questions. Now these questions are going to be a little bit easier today because of what you don't know. All right, you only know this one theorem, and you know IVT, Intermediate Value Theorem. So you don't know the extreme value theorem that we're going to learn tomorrow in the next one. We'll also learn tomorrow. So can't think of the name right now. So anyway, the function f is continuous and differentiable. Are we happy about this? Yeah, absolutely. Whew. All right. Continuous and differentiable on 0 to 4. The table above gives selected values of f on this interval. Which of the following statements must be true? Well, does our function tell us about a minimum or maximum value? Does our mean value theorem tell us about that? At least shake your head, guys. All right. And then how about this? Oh boy. Does it talk about slope? Mean value theorem does talk about instantaneous slope equaling the average rate of change. Okay, so I like that one. This one, f of x is greater than 0 through 0 to 4. Do you think that's true? I'm sorry, let's see. Are all the f values greater than 0 for 0 to 4? When you look at this, yeah, it kind of looks that way, but between 0 and 1, could it have dipped down into a negative value? Absolutely. So we decided that one's true. All right, so this one I'm kind of happy about because it at least says f prime. In this bottom option, it also says something about f prime. Okay, so mean value theorem we know is supposed to say that IRC equals ARC or ARC. All right, now what is instantaneous rate of change? What does that mean? The derivative at a value, right? So the derivative at some value. What does ARC mean? Slope. So that means like f of b minus f of a all over b minus a. All right. Okay. So if I went from 0 to 4, I could actually find this f of 4 minus f of 0 over 4 minus 0. F of 4 is 2. F of 0 is 2. So I'm getting 2 minus 2 over 4. We're just doing the average rate of change on the right side right here. Yes, sir?
Would you not have to do it from 4 to 2? Why did you do it from 4 to 2?
Oh, I'm sorry. You're right. I was just looking at this interval. So that's the one I started with. My bad. I guess I was more interested in that as the answer and didn't tell you guys about it. So between 0 and 4, do we expect that the instantaneous rate of change would equal that? Sure, the instantaneous rate of change equals the average rate of change. Okay? Somebody said, shouldn't I have done 2 to 4? And yes, I should have. So let's go ahead and look at that. The instantaneous rate of change is supposed to equal the average rate of change. So we're supposed to say that f prime of some value is going to equal f of 4 minus f of 2 all over 4 minus 2. F of 4 is 2. F of 2 is 4. So what, negative 2 over 2, which is negative 1. So this is saying that the instantaneous rate of change was equal to negative 1. But this is saying it must be less than 0. So what do y'all think is the best answer? There exists C for which this is true. Yeah. It is an existence theorem, so we're just going to say that it exists. We're not going to say that it must be less than 1 or less than 0, like this one says here. All right, let's continue. 2003, number 80. The function f is continuous. Is that good? And differentiable. All right. So now we can answer a question based on the mean value theorem. All right, so which of the following statements could be false? If f of -2 is -5, f of 1 is 4. All right, so all of these say there exists. So it's one of the ones that says there exists, you think? Okay, so this is saying from -2 to 1. So I know the interval that I should be using. All right, so for mean value theorem, I'm supposed to say that IRC equals ARC. Instantaneous rate of change is some f prime at some c value. Sorry, that's a c. All right, average rate of change is going to be f of 1 minus f of -2 over 1 minus -2. Well, yeah, I think you could. The question was, can I eliminate the ones that don't say f prime? And I think that that'll be a smart thing to do. Go ahead and write excess here instead of crossing out the whole thing so you can't read it anymore. All right, so f of 1, it says, is 4. F of -2 is -5. All over 3, it looks like. 4 plus 5 is 9 over 3, and 9 over 3 is just regular 3. So this is saying that the instantaneous rate of change must be 3, based on the mean value theorem. Well, looks like these. Is that okay?
Which ones could be false? So
Oh, my bad. Which ones could be false? Okay, so this one is not false, but true, right? Could be false. So, okay, so that one's absolutely true. There exists C between -2 and 1 such that the C value is greater than f of C is greater than f of x for all x in the closed interval between -2 and 1. Okay. Guess I wasn't ready to, I need to turn my brain around a little bit. So, yeah, let's go back through this. So when you look at A, there exists a C value where on -2 to 1, so that I hit 0. It went from -5 to +4. Yeah, so that one is true by what theorem? IVT, yeah. Intermediate value theorem says that if I'm at -5 and I go up to 4, then I had to have hit 0. All right, so now there exists a value on the interval so that the derivative is 0. Could it be true that the derivative is 0? We got 3, but okay, so it could be false, it could be true. Okay, so this one, well, what if I did instead of between -2 and 1, what if I did between -2 and 0, and I found that slope? That slope could be 0. I don't know what the slope is between -2 and 0, or between -2 and -1. So if I just close that interval a little bit, I could have that slope. So I think this one's going to be your could be false one. All right, so look at option C. There exists a C between those two values such that f of C is 3. Does f of C have to be 3 between -5 and 4? Yeah, by what theorem? IVT, yeah. And then there exists some C value on the interval from -2 to 1 such that f of C is greater than or equal to f of x. So could the value at C be greater than the value at x, at any x between -2 and 1? Yeah, sure, that could happen. But could be false. It has to be true, doesn't it? Does this one have to be true? And tell me why. It has to be true because between -5 and +4, 4 is -5. So there has to be some value on that's bigger than one of the x values. Makes sense? There exists a C. Okay. So actually, this is this you don't know yet, but this is called the extreme value theorem. And I'm sorry for giving you that, but so you would have had to answer B as false, and you didn't know that theorem for part E quite yet. But you'll know that mañana. All right, thanks for pointing out my error at the first part there. That was a good question, right? Okay, next one is continuous and differentiable, so we're super happy. We can use MVT if we need to. Which of the following could be false? Y'all know anything about this one? All right, so let's just mark that one off the list because we don't know intervals yet. Or integrals, sorry. We don't know integrals yet. Does this look like MVT or IVT? This one? Option A. Yeah, IRC is equal to IRC equals ARC. That is the mean value theorem, and that's what we're learning today. For some C between A and B. Okay, so that one looks okay. What about the next one? The derivative equals 0 between A and B. How about this one? F has a minimum value, F has a maximum value. These are actually going to be true. And this is going to be the extreme value theorem that I alluded to in the last question. So the extreme value theorem just says you have to have a max and you have to have a min. All right. So therefore, I guess the only one that we're going to say could be false is, well, hold on a second. I guess we don't know part E yet, so.
Pardon the interruption. Can I have John Weathers to room 3106, please?
Yes, ma'am. Right now or at the end?
Right now for a few minutes.
Sure. See you, bro. Okay, so let's just consider this as a picture, okay? Just so I can kind of show you that this could be false. So if I had an interval between A and B, and I graphed just a line, is the derivative ever 0 there? Okay, and even if I don't include A and do an open dot there, and now I just look at the derivative is always positive. So f prime C, no matter where C is, C can be a slider, is never equal to 0. So I just drew a counter example for part B, so that would be false. So I guess what that means is that this option E is true, even though we don't know anything about an integral at this point. Okay, so this one says let f be the function defined by f of x equals x plus ln x. What is the value of c for which the instantaneous rate of change is the same as the average rate of change? Okay, well, this time it doesn't say it must exist, does it? All right, this is actually finding one. So this is even more than just using the mean value theorem. This is actually saying, well, what is it? Okay, so we know that it must exist because this function is continuous and differentiable. Okay, f of x is continuous and differentiable. I used to have a professor that said diffable. That's acceptable, but I never liked it when he said that. So I'm going to say differentiable. Now, once we say that it's continuous and differentiable, that means that MVT can be used, right? MVT. We can say by MVT, instantaneous rate of change equals average rate of change. What's the value, C, for which the instantaneous rate of change is the same as the average rate of change? It says it's at x equals c, so f prime at c equals the average rate of change. Average rate of change is going to be f of 4 minus f of 1. I hear a calculator tapping. That's good news. So go ahead and type in f of 4. That'd be 4 plus ln 4. Minus f of 1, that'd be 1 plus ln 1. We know that ln1 is 0, but I'm still getting a 4.38 divided by 3. So I'm going to go a few more decimals than what the calculator, than 3 decimals. I'm going to go 1462098 or something. Okay, I'm going to use what's in my calculator. Now, pause right there. What did you find? Well, you found the average rate of change, and you're saying that it's the same as the instantaneous rate of change, but you found the average rate of change and the instantaneous rate of change. But what does the problem ask? For what value at C does this happen? Okay? So what you'll do is you'll go back into your y equals in your calculator and type in x plus ln x. And then you'll do y2 in your calculator and make sure that it's that full decimal representation, 1.46209.8. I think there's a couple more decimals, 2.1 maybe. And then you go second trace, second trace, which is actually the calculate button, second calc, and then I think 5 would find the intersection. So you're going to find the intersection. So f prime c equals this at c equals, and then you go ahead and find that number. If they were really mean to you, they would have put a 1.46 up here, right? And as an answer choice. All right. You guys. Did you find the intersection? And what'd you get? What'd you get? Why did I not get that? I got 1.24 for 1.244. My answer key says that it's C.
I took the derivative of x plus ln x and set it equal to 1.46 and solve for x.
Oh yeah, that's another way to do it. So, I don't see anything wrong with what I did though. That has to be the function. What is the value for C, which is the instantaneous
You didn't do
rate?
the derivative of x plus ln x. You just did f of x instead of f prime.
When is F equal to that? Oh, yep, that's the problem. Sorry. So when you graph this, this shouldn't have been y1. This should have been 1 plus 1 over x, right? There we go. Thank you. All right, we had to take the derivative of that. So we need to find out when f prime equals that value. Thanks. Calculate, intersect. Uh, 2.164. There we go, 2.164. All right, math is messy sometimes. Go make a mess. Okay, so we have some more mean value theorem questions. How many more do we have? 1, 2. All right. I'm thinking to leave you guys with it, but maybe these are all a little bit different. So this is saying that we have twice the differentiable functions, f and g. So I guess that's good because we need it to be differentiable. Okay. F prime, g, and g prime have various values in the table. Explain why there must be a value between -1 and 1 such that the f double prime equals 0. Okay, well, if we're going to try and use the mean value theorem, we know that the instantaneous rate of change, IRC, equals the average rate of change. Okay? But pay very close attention to what you are actually computing this time. This is saying f double prime, right? So we're saying that f double prime at C should equal f prime of B minus f prime of A all over B minus A. Now that should make intuitive sense, but what I'm doing in this question is just allowing you to go that far. Okay? So it used to say f prime, and then there were not any f primes on your f of B and f of A. Well, this time we're down a level from that. Okay? So instead of B and A, we're going to be using 1 and -1. So f prime at 1 minus f prime at -1. 1 minus -1 is in the denominator. Go and find those values in the table, maybe. F prime at 1. 0. F prime at -1. 0. Over 2. So I'm getting 0 divided by 2, or just 0. So by MVT, we're getting that F double prime at some value is 0. Okay? We kind of explain it. We kind of explained it. We're just using the mean value theorem. What I probably should have done is said F is twice differentiable, therefore we can use the mean value theorem. Okay? All right, I think that this is a good one to stop on and let you guys practice. Okay? So give that one a go. You have 10 minutes to show it to me.